Alright guys, so we're going to start chapter 5 on section 1 today. The title of chapter 5 section 1 is called Fundamental Identities. Okay? The identities that we're going to cover today, most of them you already know them. So I'm just going to refresh your memory on them, okay? For example, you need to know that sine of some angle is the same thing as saying 1 over cosecant, right? Yeah. So then could you then say that cosecant is the same thing as 1 over sine? Right? We've learned that before. Agreed? So you already know this. So then what would you say then that secant is? 1 over cosine of an angle. Right? And what would then cotangent be? 1 over tangent of an angle, right? You already know those. Agreed? Nothing new there. We're good? Hopefully. Those are known as the reciprocal identities. And it makes sense because you know what a reciprocal is. Agreed? Okay. Then we have something called quotient identities. And you already know this as well. You know that tangent of some angle is the same thing as saying sine over cosine, right? And quotient. The names really are not that relevant. You just need to make sure that you know them, okay? So therefore you know that cotangent of some angle is what over what? Cosine over sine. Right? None of this should be news to you. All of this have been used at some points during this year. Agreed? Which takes us to brand new material. The Pythagorean identity. Pythagorean identities. Question, what's the Pythagorean theorem? Oh, I'm sorry, you guys use A. A squared plus B squared equals C squared. Agreed? Alright. Let me ask you something. If I draw the unit circle, sort of, beautiful unit circle there, and then I create a triangle here, that's a right triangle. We used that triangle earlier this year to come up with all the values on the unit circle. Agreed? You said technically, because we're on the plane, this is an x distance, right? And this is a y distance, right? And then we're able to figure this out right here, correct? We then later learned that on the unit circle, the x is the same thing as saying what? Cosine. And y is the same thing as saying sine. So, could I then say cosine square of theta plus sine square of theta? Well, on the unit circle, remember what's always the radius? You guys recall that? Yes? Okay, one more time. So this is the unit circle. To be on the unit circle, the triangles that always have a radius, the circle had a radius of 1, therefore this triangle has to have the hypotenuse of 1. Agreed? Then this is x, that's y, right? And we learned that x is the same thing as cosine. y is the same thing as sine. So if I go back in here, and I know you noticed that I wrote it as x squared plus y squared. Most of you guys know the Pythagorean theorem as a squared plus b squared equals c squared, but it could be any variable. Agreed? So if I write this using this triangle, that would be x squared plus y squared equals to 1. Agreed? Pythagorean theorem on this triangle. But you know that x is the same thing as cosine. So then you could say cosine theta squared plus y is the same thing as sine theta squared equals to 1. You guys with me? Now, when we are, I don't know if you noticed throughout your homework that you did last time, when you square a trigonometric function, to make sure that we don't confuse what's being squared, notice how the entire cosine is being squared. The way we write that is we put the 2 right in front of the cosine and then the angle. Okay? So this becomes cosine squared theta plus sine squared theta equals to 1. You guys with me? Yeah. Do you understand why that works? And why this would be an identity? Mathematically, it makes sense. Agreed? Well, what if we take this one? So this is one of the ones you're going to have to memorize. So just go ahead and box it, highlight it, or something. Okay? I'm going to take this identity, and I'm going to divide every term by cosine squared theta. So here's what I'm going to do. Cosine squared theta plus sine squared theta equals to 1. I'm going to divide the entire thing by cosine squared theta, right? Now, algebraically, I just want to make sure we're all there. That's the same thing as saying cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. Algebraically, right? Do you guys follow me? Is that algebraically correct? What's cosine squared theta divided by cosine squared theta? 1. What's sine over cosine? What's 1 over cosine? That's another identity you need to memorize. What's up? By cosine squared theta. Why not? I mean, remember, algebraically, that's a good question. Algebraically, as long as you do the same thing to one side to the other side, it's correct. So the reason why I did that, I was like, okay, maybe I can remember that equations, you can manipulate them in all kinds of ways algebraically to make it work for whatever you have. Notice that we don't only have sines and cosines, right? If everything was sines and cosines, then there will be absolutely no need to come up with the one that I came here. But sometimes you're going to be dealing with problems that have tangents and secants, and then you can use this one. Okay? Yes, sir. Yes. So now, what I want to do is we're going to take this one right here, the cosine squared theta plus sine squared theta equals to 1, and I want you to divide it by sine squared theta. Okay? So, gentlemen, so cosine squared theta plus sine squared theta equals to 1. This time I want you to divide it by sine squared theta. What's cosine squared theta divided by sine squared theta? Cotangent squared theta plus 1 equals to 1 divided by sine is, right? Now, to make this look for now, those are the 3 that we're going to work with today. Okay? Now, here's my question. Does it have to be written that way? Is this the same thing as if I say cotangent squared theta is the same thing as saying cosecant squared theta minus 1? Yes. Your algebra skills are going to come into play a lot. Okay? But here's how they look as identities. Those are the 3 that you need to memorize. Okay? You can manipulate them in any way to help you out with whatever problem that you have. What we're going to do is we're just going to play with algebra and make sure that your algebra is there. The goal of us doing all this is eventually going to come until we go into section 3 or 4 of this chapter. Finally, we're going to be able to apply this. But for now, we're just going to play algebra. Make sure that you can algebraically manipulate all these things. Okay? All right. So now, you ready for some problems?
Yeah.
All right.
Because there's no grass right now.
You can use...
No grass right now.
How much I hate graphs, like doing algebra makes me so happy.
Well, I'm glad. I'm actually...
No, I'm not even joking.
Are we gonna have to graph? Oh, we're gonna have to like.
No, you do not. Graphing... All right, listen. Get back. Come on, guys. We're going to use these expressions just to simplify. That's all we're doing. Just like your homework was simplification, it was factoring or whatever. Well, yeah, that was your homework. Factoring. We're going to use it to simplify things. Okay? That's all. That's the instructions for all this problem. Simplify the problem. Okay? All right. Problem number 1. Sine x times cosine square x minus sine x. All I want you to do is to simplify the problem. Okay? All right. Simplifying means that you can as little terms as possible. Agreed? All right, here's my question to you. How many terms does this problem have? 2. Term number 1 from here to here, term number 2. Do those terms have anything in common? Can you factor out a sine x? Sine x times cosine square x minus 1.
And then you can change that.
Agreed?
You can say that's negative sine squared x.
So let me ask you something. You're like, at this point, you're like, hold on. This looks something like we've just discovered earlier. Agreed? All right. Hold on. Sine square x plus cosine square x equals to 1, right? How can I manipulate this so that I have cosine square x minus 1? So could I then say that cosine square x minus 1 is the same thing as negative sine square x? Yes? Right? Algebraically, do we all understand what just happened?
Definitely.
I subtracted the 1 and I brought it to this side. And then I subtracted the sign and I brought it to that side. Cool? So then, now you know that cosine square x minus 1 is negative sine square x, right? So what I'm going to do is I'm going to replace it in here. So then this problem becomes sine x times what? Right? You guys with me? What's sine x times negative sine square x? Cool? We're just simplifying. Simplifying is try to keep as least terms as possible. If I factor, I'm going to have 3 terms. See what I'm saying? We're simplifying. Okay? All right. Guys, that was an easy one. I need you to, I'm going to be honest, in chapter 5, you have got to ask questions. The moment you get lost. Okay? Any questions on problem 1 before we move anywhere else? What's up? Yes?
Could you square root sine squared x and make it like
Ooh.
cosine x?
The whole, I see what you're doing. Trying to take square roots. We're eventually going to get there. For now, we want to use the identities as they are without changing them with roots and whatnot. But that's a good point.
I just feel like, could you like plug in cosine squared x minus 1 into sine x?
No, because it's not squared. You would have to then take the square root of it, and yes. But that's going to make the problem more complicated, honestly. Okay, I see what you're saying, though. I agree. No. Fantastic, because that tells me that, I mean, you're actually getting to, like, where we're going to get in 5-4. So you're thinking ahead. Good. Any questions, guys? All right. These are just going to take practice. So here's the second one. Cosine squared x times cosecant x minus cosecant x.
Wait, can you say it again? Sorry, it's really hard to. Oh wait, you're saying I can see it.
All right. Suggestions. Okay, you ready? Cosecant x times what? Cosine square x minus 1. Alright, I know some of you guys see what's going to happen here, but hold on so that those that do not see it can watch, okay? So I know if you know, just you can finish the problem on your own, okay? Here's my question. This looks like one of the Pythagorean identities, right? This looks like cosine square x plus sine square x equals to 1, right? Is there a way that I can manipulate this to make it look like that?
Yeah, we did it last.
We just did it, but I feel like some of you guys got lost. So I'm going to actually show every step. Minus 1, minus 1. So that becomes cosine square x plus sine square x minus 1 equals to 0, right? Well, I want this to be alone, so I need the cosine in that. So what do I need to do with the sine? Subtract it. Agreed? Therefore, cosine square x minus 1 is the same thing as saying negative sine square x. Agreed? You guys with me? Alright, so then how can I go back and use this into what I was doing? Cosecant x times negative sine square x. Alright?
There must be some extra because of the reciprocals.
Dude, you're right on the money. Okay, let me ask you something. At this point, most of you are like, okay, I think we're done. However, we have more than just Pythagorean identities. How can I rewrite cosecant? Alright, did I lose anyone there?
No.
Oh, I got it.
That's just like common.
Alright, so then, if I multiply these things out, this becomes negative sine square x over sine x. Agreed? Which is basically, for those of you that are maybe having some trouble, this is the same thing as saying negative sine x over sine x. Agreed?
Let's cross that sine x out over there. Yeah.
Negative sine x. And that's the simplification of this.
Okay, I'm excited. There's no graphs.
Okay? Let's do this. And yes, this is one of my favorite chapters in the whole book. But yes, it is one of the most complicated.
Common denominator. This one needs to have another one. Slow down. Get to this here. Get to this here. Get to the common denominator. Get to this where you don't know the bottom of the common denominator. So I mean, like, once you get the common denominator, like 1 plus sine x, common denominator.
Yeah, that's what it is. So it's just 2 over. Wait, 1 plus 1. When you're adding them. 2 over sine squared x.
Yeah, when you put 2 sine squared x.
I'm gonna do a mod.
Wait, is it 2 minus sine squared x?
No, it's 2 over sine squared x.
2 over sine squared x?
Yeah, because you're doing the 1 on top. Well, you have to come to the 2. Those are the ones that positive tables. What?
Oh, yeah.
Yeah, so it would have been a pos. The negative 1 would be positive. No. It's positive. Oh, okay. So it's still plus 1.
you have one positive sign x, you have one positive sign x, and one negative.
Yeah.
That's why it will be a negative sign squared x.
Yeah, what's that? So it's the negative two. Yeah, that makes sense, but wouldn't it still be the plus one? Because when I did the now that is only negative there.
No, it's two. No. Okay, so yeah.
There is no minus one.
Yeah, I think it's negative. One minus sign squared x.
Yeah.
That's what I had.
Okay. So it's one minus. Oh, I thought you said you didn't have it. Okay. Yeah, it makes sense. So it's one minus. Yeah. Well, because sine squared is equal to sine squared x is equal to what? One minus two cosine squared. So you do, well, you don't include the one. Yeah. Well, it'd be one minus cosine minus one. So that'd be cosine.
So sine squared x equals one minus two sine squared x.
Yeah, one.
But I mean, if you do that, is it already simplified once you get to that point? I have 2 over 1 minus sine squared x, but I mean,
Which equals.
yeah, I know that's what it says. So like, after that, though, you can't like.
Because if you have one minus sine squared x is equal to.
Oh yeah, I just realized. I don't know how to
But I
say
don't
it.
know. I feel like.
I feel like there's more to it.
Oh, you got it jacked up. Oh.
I was thinking the root.
Hey.
Yeah.
No, he didn't.
No, it's still going.
That where you had earlier. 1 over cosine of theta.
In the beginning?
I mean, that's the most simple you can do. Wait, but 1 squared is it 2?
1 squared is 1. No. Okay, yeah.
People gonna be watching this
1
video.
squared is 1.
We're like, what the
So root 2 over cosine of theta.
Yes.
But like when you simplify that, you get it.
Oh, wait.
Yes. How do you get that's the
One minus sine x.
Andy's a genius. Wait, what is
What?
it? Andy figured it out. It would just be 2 secant because if it's 1 over cosine squared x, that's the same as. Oh my god.
Wait, what? I don't get it.
Okay.
Oh.
All right, I'm about to go over it.
Bring it back.
I love a reporter. Wait.
What? No, we did it wrong.
Stop it.
Why? How?
Because take it like 1 over cosine is what?
That's blind kids playing football. That's the best video of all time. That's the best video of all time. Have you seen that video? The blind kid playing football in an interview. He's like, football's just my passion. I just love playing it. And then the video starts going.
He's still like running around.
The video starts going, and he's just running around the football field, and he like doesn't even know what's going on. Like the play's like on the other side of the field, and he's still running after them. And then it's like.
All right, guys, I'm about to go over this problem. You ready? Okay. Check step by step what I'm doing and find out where it is that you're getting stuck if you haven't gotten the if you don't get the same thing that I do, okay? Ready? All right, if you're watching the video, here's the answer for number 6. All right, pause the video at this moment and check my work, and then press play when you're ready to go. Okay? Number 7, guys, let's do this. All right, number 7. Cosine square x plus cosine square x times tangent square x. All right. Cosine square x plus cosine square x tangent square x. Suggestions.
Hold on, can I just write the problem?
Hold on. Both of this have what in common? I'm going to factor out a cosine square x. Okay. Questions in here? Yes.
What just happened to your other cosine squared x?
Guys, alright, guys, I'm gonna be honest, hold on. I love your excitement about this lesson, but you're getting ahead of yourself because you think you know it, and then you're not knowing the material right. So allow me to explain and show you the material before you shout out something, okay? Look, if you turn this into sine and cosine, you would have still gotten the same answer, but it would have taken you longer. First of all, I noticed that both of these terms have in common a cosine. I factor out a cosine. Cosine square x times 1 gives you that, and cosine square x times that gives you back in that. Are we cool? The reason why I did this is because this looks like something that I know. Go back to your identities. What is that equal to? Right? Did you go back to your identities? Look at this. Here's my identities. 1 plus tangent squared theta equals to secant squared theta. So, 1 plus tangent squared theta, x equals to secant squared x, right?
Yeah.
Then at this point, I'm like, okay, I think I can do more if I use reciprocal identities.
Cosine squared x.
This is the same thing as saying 1 over cosine, right? Then what?
I mean, it's reciprocal. Yeah. Just one. Wow. Did you draw that little box like you're done with the problem?
Yes.
First thought also might be-
But let me ask you something. Do you remember how basically if you have a function and it's reciprocal, aren't they just going to be 1? I mean, you could have seen that you could have gone from here to here. But if you didn't, you know that secant is 1 over cosine. Is anyone lost how I went from here to here?
No.
Because if you are, that's just multiplying a whole number by a fraction. That's really what I did. Like going back to algebra 1, no, not even algebra 1, like 8th grade, 7th grade math. This times that gives you that, and you leave that alone. Okay? Alright, moving on. Cosine square x minus 4 over cosine x minus 2. And this is going to show me whether or not you did your homework.
I tried.
What could you do to the numerator? Alright, so let's pause. Do you guys see how you have a difference of squares? Is this a square? Is this a square?
Yeah.
Is it subtracting? Difference of squares. What's the square root of cosine squared? Cosine. What's the square root of 4? So difference of squares says that you take the square root of both of them, and then one of them you make them a plus, and one of them you make it a minus. Agreed? All over cosine x minus 2. What's going to happen here?
It's gonna cancel out.
Wait. Oh, never mind.
Right?
So the cosine x plus 2.
No, because it's cosine x plus 2, you can also say cosine x plus 1 plus 1, and then you can reverse that.
No. Stop. Right there. Stop. Yes, but no. We're not going there. Cool? Yes. The purpose of this is to simplify things, not to make them more complicated. Whatever he was saying, ignore it. Just stop there. Right here. Okay? Alright, guys. I'm losing you. We got 4 more problems. Come on, stay with me. Number 9. Cosine square x times secant square x minus 1. This problem is very easy if you know your identities.
Know yourself.
Go back to the identities.
Oh yeah, the tangent one. You just gotta move it around a little bit.
What do you recall about this one with the secant? Secant is the same thing as saying what?
That's just tangent squared.
1 plus,
It's just minus
right? That's one of the identities that we discover at the beginning. I wanted to say secant square x minus 1, so what do I need to do?
Just move that one over, just real quick. Yeah.
So then what do we know now?
Well, that equals tangent squared.
Agreed?
Just put one over. Just put the little
Alright, at this point, you can go view.
sign over the cosine.
Sine over cosine, but it's sine squared over cosine squared. And what's going to happen here?
Can't simplify real quick. So it's just sine squared.
Cool? I hope you're discovering that, like, I wasn't joking about that homework. If you did that homework, I think this could be very simple. Or not very simple, but relatively easier. Right? Okay. Questions to number 9. Okay. Yes.
What I did was I just changed secant squared at to
1 over cosine.
and then I got 1 minus.
There's multiple ways of doing it. I agree.
I got 1 minus 1 over
Yep.
cosine squared x.
Alright, where am I at? Number 10? Number 10. Cosine x times 1 plus tangent square x.
Okay, so that's 1. It's 1. It's 1.
Cosine x, what's 1 plus tangent square x, guys?
Secant squared x. Wait, no, it's not 1. Yeah.
It is 1.
Agreed?
Yeah. No, it's not because that's squared.
Oh, yeah.
Yeah.
Okay?
I would.
Guys, this is the same thing as saying 1 over cosine square x, right?
Thinking out loud.
Which is the same thing as saying cosine x over cosine square x. Agreed? What's going to happen here?
It's gonna cancel, so it's 1 over cosine x.
1 divided by cosine x. Yes? Which is secant of x.
Starting to get a little
Alright, we're going to call it a day there. I feel like you're ready to practice on your own. Okay? Listen to what the assignment is. So, if you're watching the video especially, okay? Alright. 4th period, listen to me. You have to be working on this. If I get a bad report from the sub, you'll be consequences. This is your homework. There is 21 problems, but read the instructions.
1 to 10 on
1 through 10 are mandatory. 11 through 21, I'm debating. Maybe I'm going to make them extra credit. We'll see. But 1 through 10 is mandatory. That's your homework. If you don't want to do 11 through 21, don't do them. Okay? But 1 through 10 is mandatory. You're going to need, obviously, your own paper. There's no way you can fit them in here. Please, when you are doing your homework, notice how I'm taking mine, and I know that I'm taking up a lot of space. I need to be able to follow your work. If you write really small and I can't tell where you went from one step to another, and then you got the wrong answer on a test, I wouldn't even give you any partial credit if I can't follow your work. So please stay organized. I'm sorry if you have to use a lot of paper. Just use it. Cool? Any questions about the assignment? Yes, sir.
Will we get that piece of paper? Like, the one that you were asking?
Yes.
Well, I thought you said